Okay, so we're on to 8.3, slope of a line. So, slope. What is slope? Slope is the steepness of a line. It's also considered rise over run, or you can see change in y over change in x. Now, another way to write change in y over change in x is that triangle. That's a delta, actually. It's a Greek symbol, and it means change in for math and science purposes. So change in y over change in x. So that's a little short thing. So now you know what the triangle means in math and science terms. Okay. So for this one, we have a little graph over here. My example problems, we're going to find the slope of the line between, or you could say between, consisting of 1, 2, and 4, 3. So first of all, we are going to we're going to graph this. We're going to see this, we're going to figure out the slope based on just the graph in this case. So I'm going to graph it, so it's 1, 2, so I'm going to go over 1 for the x coordinate and up 2 for the y coordinate, so that's my first point. And then I'm going to go over 4 and then up 3, so this is my my 2 points, and then my line will be somewhere like this. It's not perfect, but it's close enough. Okay, so that's my line. Now, we said the slope is the steepness of this line, so you can look at it, but you can't tell how steep it is. You can't tell the slope. You can tell it's not very steep, but you don't know what the slope is. But the slope is rise over run. So we're trying to figure out how much is it rising, so how much is it going up and going over to get from this first point to the second point. Well, if we look right here, it's going up 1. So it has a rise of 1. So we're doing rise over run. Is another way to write rise over run. So the rise is 1 at the top. Now, run means how far is it going to the right or the left. So rise involves up or down. It could be negative. It could have a negative rise when run is left or right. So we have 1, 2, 3. So it's running a positive 3. Since we're going in for the rise, since we're going in the up direction, that is positive, so that's why it's a positive 1. If we were going in the down direction, it would be negative. Likewise for run, if we're going to the right, then that is a positive. If we're going to the left, it is negative. Now, again, so our slope in this case is 1/3. Okay? You can also think of it, you can also go back. So if I look from here, if I start from this point to go to this point, where I need to go down and then to the left. So how much am I going down? I'm going down 1, so that's a negative direction. So we could think of the rise as a negative 1. And then the run, we're going to go 1, 2, 3 to the left. So that's a negative 3. Negative 1 divided by negative 3 is the same as 1/3, so we get the same thing either way. It doesn't make a difference. So this is how we can look at it. If we're given the graph, we can find the slope really easily. But you might not always have the graph, and you might not going to want to have to graph something in order to find your slope. So we're going to give you the formula for slope. So slope equals y2 minus y1 over x2 minus x1. And I'm going to kind of explain that in a second. Okay, so if you're given 2 points, so you have your first point and your second point. Okay, so your first point will consist of x1, y1, meaning that x and y, the reason why I have those little subscripts, I'm saying that those go together. You know how a certain x has to go with a certain y? I want to make sure that you show that those go together. Likewise, this one is, oh my goodness, just pressed the wrong one. Okay, there we go. So, likewise, we know that, oh my goodness, why? I am just going crazy. Hold on, oh no. Okay. Second point is going to be x2 comma y2. Okay, so the x2 goes with the y2 and the y1 goes with the x1 goes with the y1. It's very important that you keep them together. Okay, now slope, I'm just letting you know okay, sometimes we have certain things that represent variables, or like certain things and formulas. You know how we have L and W is typically length and width. Well, in this case, you're typically going to see slope as M. So I'm just letting y'all know that now. If I ever use M, I'm meaning slope most of the time. Again, does that mean every variable ever used for M is slope? No, but I'm just giving you that information. Okay, so the slope is constant for any line. We know, if you know what constant means, that it doesn't change. Means it doesn't change. So that means it's going to have a constant slope. So the slope from every point of a line is going to be the same. So if you pick any 2 points on that line, you will still get that same slope. You might have to reduce the fraction, but you'll still get it. So now we're going to the examples, and it says find the slope of the line through the points, those 2 points, okay? So it doesn't matter which one we pick as our 1 and our 2. So this could be our 1 and 2, like the x1, x2, okay? We just have to make sure we're consistent. So if this is my second one, then I'm going to put 8 first, because I have to do the y2 minus the y1. So 8 minus 3 over x2 minus x1, so it would be 4 minus a negative 2. So really that's going to be plus. So equals 8 minus 3 is 5 over 4 plus 2 is 6. So my slope is 5/6. But again, it doesn't matter which order you choose. So if I were to say this is my second one and this is my first point, I could still do that as long as I'm consistent. So I'm going to say y2, which is 3, minus y1, which is 8, over negative 2, which is x2, minus 4. So that's going to give me a negative 5 over negative 6, which reduces to 5/6. So again, same thing. Does not make a difference. You just have to make sure that they match up. If you're gonna put the 8 first over here, then that means the 4 has to be first over here. Okay? Or 3 first, then the negative 2 has to be first. Now we're looking at y equals 3 and x equals 4. So we know that y equals 3 is a what kind of line? We said that it is a horizontal line, and it's going to be a horizontal line at 1, 2, 3. So I'm going to say that this is my line, y equals 3. So if we're looking at this, we're trying to figure out our slope. Well, if you look at it, it rises to run. You can't do anything. This actually, if it's y equals and it's a horizontal line, it has the slope is 0. That's something you just want to know. Saves you the time and hassle. But I can prove it to you. I can pick 2 points on that line. So I know that if y equals 3, I can pick 1 and 3, and I can pick 4 and 3. It doesn't matter, because does y equal 3 on both of them? Yes. So I can still use that same formula and go 3 minus 3 over 4 minus 1, which is 0 divided by 3. And we know that 0 over 3 is the same as 0, so that is why we have a slope of 0. Now if we look right here, we have x equals 4. We know that that's going to be a vertical line at 1, 2, 3, 4. Okay, so what does it rise up to? Well, it just keeps rising. Okay, this means the slope, there's no slope. So this is something you want to know. Or you might hear it as undefined slope. Slope is undefined. So that's something good to know. again, we can prove it to, I can prove it to you. So if x has to be 4, it's going to have 4 and 2 and 4 and 5. Okay? As long as x equals 4, it's on that, those are the points. So I'm going to do 2 minus 5 over 4 minus 4, which equals a negative 3 over 0. But you can't have over 0. That's why it's undefined. So that's why we have that. So, thus, horizontal lines have 0 slope, and vertical lines have no slope. Get it? Got it? Good. Okay. Now, how do you use slope to help graph a line? Okay, so we're going to look at this example. That's kind of our posing question. Okay, so we want to have a point 1, 1, but the line has to have a slope of negative 1. So it's basically saying we're finding a line that has a slope of negative 1 and includes the point 1, 1. So I'm going to graph 1, 1. And I know that the slope is rise over run. And negative 1, I can write that as a fraction. That's negative 1 over 1. Right? So that means I'm going to rise a negative 1. So really I'm going to go down 1. And I'm going to run, positive 1, which means I'm going to go to the right 1. So that means that's my next 1. I'm going to go, so then I'm going to do it again. I can do it again. Down 1, down 1, over 1. Down 1, over 1. So I'm going to follow that pattern. So I can keep doing all those dots. But likewise, we want it to equal negative 1. Well, 1 divided by negative 1 works as well, right? That still gives me a negative 1. So that means I could start from back to this point, and I can go rise a positive 1, but run a negative 1. So that means go to the left. So up 1, negative 1. So you can kind of reverse the pattern in the opposite direction. And look at how many dots I was able to draw. Not the best line ever, but it's a line. So there you go. And what is the slope of this? So in order for us to find the slope, we need to find 2 points. And then we can use that, then we can use our slope formula. So I'm going to try to use whole numbers because I don't want to involve not whole numbers. So I'm going to just kind of guess and check. I know, because I already did this, that 1 will work in it. So if x equals 1, then that will be 6 minus 2y equals 14. So subtract 6, so negative 2y equals 12, which, that's wrong. Hopefully y'all all caught that. So that would be 8, so divide by negative 2, so y equals a negative 4. So y equals, so my first order pair is 1, negative 4. Then I'm going to try x equals 2. Again, I kind of tried these out. X equals 2, so it would be 12 minus 2y equals 14. It would be negative 2y equals 2. Y equals a negative 1. So we have 2, negative 1. So now that we have 2 points, we can easily find the slope by using our formula. So I'm going to say this one is my second one. This is my first one. So I'm going to do negative 1 minus a negative 4 over 2 minus 1. So that's plus. So that's going to be 3 over 1, which equals 3. So my slope is 3. There you go.